So this class is about building multi-rotor aircraft. So you've seen quadcopters, some people call them drones. People fly them around. They've been in the news a lot lately. And they're a really interesting kind of electronics project. And it's something the students are pretty interested in. And so we're using it to teach them how to build printed circuit boards and simple electronics, and then make the software work along with that so that they'll fly and they'll be able to control them by remote control. So this is a capstone class, so the students are mostly seniors from computer science and electrical engineering, and we have one person from mechanical engineering. And so we kind of targeted at seniors. The class is pretty small because it's pretty intensive as far as teaching it and managing it goes.
I was mostly hoping to learn about, first of all, hardware design, because I had never done any of this before. So all the PCB design, all that sort of thing was new to me. And that was something I felt like I should have learned by now, just being a computer engineering major, but I've always been more interested in software, so I just never took a class like this before. So PCB design was a big one, and then also because I've been interested in quadcopters for a while now, I wanted to learn how the software actually worked.
I was really hoping to, have a fun project I could work on. Kind of being a class, it would kind of force me to work on some things, kind of dig into it, have more resources available than just something I was doing on my own.
The skills that you learn in building one of these quadcopters you could use to build all kinds of electronics. It's the same basic process that you use to build iPhones or laptop computers, or if you're a maker and you want to build some electronics for a piece of electronics art or any other project, the same kind of tools and techniques are what we're teaching them.
Everybody, all of our groups, we designed the layout of our circuit boards from scratch. So we kind of had some parts, we kind of had a circuit we started from, but everybody kind of customized their circuit, and then we all designed the final board that we made. So each group has a different board.
So what they've learned so far is they've learned about printed circuit boards. We've talked a little bit about how they've manufactured, and then they've spent a lot of time learning how to design the printed circuit boards. So that means building a schematic, which sort of defines the electrical connections between the components on the board. They also have to design kind of the engineering information about the parts themselves, so how big they are, where the electrical connections need to be for a particular LED or a capacitor or a microcontroller. Probably the biggest and hardest part is actually laying out the board. And that's where they define the shape of the board, and they have to take into account a bunch of different physical constraints. The motors have to fit right, it has to be the right shape. There's a limit on how large a board we can manufacture. And there's also some kind of complicated electrical constraints that they have to meet to make sure the motors get enough power, to make sure the radio doesn't get interference from the motors, things like that.
One of the cool things about this class is a lot of people came in with different backgrounds. And so some of us knew how to do the software, some of us knew how to do hardware. Some people, I think I might be the only one, but I came in knowing a lot about quadcopters and not too much about the hardware or software behind them. So I think if you have any interest and you feel like you're lacking in one of those areas, it's a really good class to both learn something and do something fun, a fun project.
So building something and seeing how those parts work together, I think, is really valuable. Employers really like hands-on projects. If you do a programming class, maybe your code worked and maybe it didn't, but if we have some video of your quadcopter flying, then clearly you got your quadcopter to fly. And that's not something that can happen by accident.
The proof is in the flying quadcopter. During the course of the quarter, I figured out a goal and I built the product, got the product working, debugged everything, and then at the end of the quarter I had something to show off. That's not something you really do in a lot of your classes. So I think it's really important to kind of round out your education where you actually build something. Fully follow a product through from start to finish. Set a goal. If your goal is to get a flying quadcopter, go all the way through, do all the steps until you have a working product that you can show off. Not just for your own education, but also it's a great thing to put on a resume.
There's a lot of interest among the students and also among their potential employers in building things. There's the Internet of Things, where everything is going to be connected. And really an Internet of Things device is in a lot of ways very similar to this. It'll have a little microcontroller which provides a little bit of compute. It'll have some radios and some sensors. And so they're prepared to go out and build that kind of stuff. And they know what goes into it, and so if someone asks them someday to go build a little gadget, hopefully they won't think that that's overwhelming. They'll say, oh, I know how to do that. I hope that some of them will want to go out and actually build real stuff. It's lots of fun.